The first thing we do is install loopback CLI globally. This will give us access to the lb command that we can use to build loopback applications. Next, we will create a folder called egghead loopback and cd into it. We run lb app in our new directory to create our loopback API project. This will prompt us for a couple of things. First, it asks us the name of the application. We accept the default. This is the name of the directory that we are in. The second question is which version of loopback we'd like to use. We pick version 3.x, which is the current version. The last question is the kind of application that we'd like to create. We accept the default, which is an API server with local user authentication enabled. The basic project will be created and the dependencies will be installed using npm install. After the installation is finished, we can start the API by running node or npm start. This will print out two URLs, to the API and to the Explorer. When we open the first URL in the browser, we see a status message. This message shows us when the API was started and the uptime. The second URL shows us the API Explorer that can be used to interact with the API. It currently shows one model, the user model. This built-in model is enabled because we selected an API server with local user authentication. Inside the loopback project, we run lb model. This will prompt us for the model name. A model name tends to be singular, so we enter product. The data source we use is the default inmemory DB. We pick persistent model as our base class. This will give our model a set of basic operations like create, read, update, delete, and a few more. Hit enter to expose the product via REST. We accept the default plural form, which in our case will be products. Then we hit enter to add the model definitions to the common folder. Our product model has been created and we can now add the model properties. The first property we add is name. It is of type string and we want it to be required. We don't want to add a default value. The second property is price. Price is of type number, it's also required, and again, no default value. We're done adding properties, so we hit enter one more time to quit the dialog. We now start our server by running node. When we open the API Explorer in the browser, we see our new product model. Here we can see all the operations that got inherited from the base model. Let's take a look at some of these operations in more detail. To retrieve a list of the products, we make a GET request to the /products endpoint. The result is an empty array because we did not add any products yet. To add a product, we make a POST request to the /products endpoint. In the data field, we define our product using JSON and submit the data to the API. When we look at the response, we see we have a validation error. This is because we didn't submit a price property. When we add the price property and submit again, we will see that the product got created. To verify this, we can look at the products endpoint in our browser and we see that we have an array with one item. We can add a second product, submit it to the API, and we see it got created. To change an existing product, we can make a patch request to the /products/ID endpoint. As a parameter, we take in the ID of the item we want to edit and the new payload of the changed values. Let's change the price of coffee to $2.99. We execute the command and we see that the price got updated. To remove a product from our API, we make a delete request to /products/ID. We take in a parameter of ID and make the request. In the response, we can see the number of items that got deleted. When we look at our list, we see we only have one product left. Let's open our editor and see what got added. We open model config.json and see that the product got defined with some basic parameters. In common/models, we see two new files. Product.json is the model definition. Here we see the base model that we inherited from and the properties that we added. Product.js is the model class. This file can be used to customize the model behavior. The default data source for a loopback API uses a connector that persists the data in memory. This means the data will be lost when we restart our process. When we stop the server and we start it again, we hit our /products endpoint and we see we get an empty array. In development mode, it can be useful to persist this data temporarily. To do so, we open datasources.json and add a new file property. And in this file property, we give the name to a JSON file. We hit save, we stop and start our server, we create a new property, and we verify it's there. In our editor, we can take a look at db.json and see how the product got persisted. Let's add a development mode to our loopback project. We install nodemon as a dev dependency, and when the installation is finished, we open up our package.json. Inside the script section, we add a dev key, and as a value, we enter this string. This will watch the common and server folders and restart the loopback server when it detects changes. This saves us from manually restarting the server all the time. We start the server by running npm run dev and open a second terminal window. When we edit one of the source files, we see that the server restarts automatically. Inside the project, we run lb model category. It takes the model name from the command line so we can accept the default. We use the default inmemory db data source, the default persisted model base class, accept to expose the category via REST, and accept the default plural form. And we accept to create a common model. Our category model has been created, and we can now add the model properties. We add one property called name. We select type string, set it to be required, and add no default value. As this is the only property we need, we hit enter to quit the dialog. When we look at our project, we see that the category got defined in the model config, and that the category definition and its class got created in common models. Now let's create a relation between the category and the product model. First, we run lb property to add a property to the product model. We select the product model, use category ID as the property name, select type number, we don't make it required, and we don't use a default value. Then we run lb relation. We select the category model, select relation type has many, and select product as the second model. The name of the relationship will be products. So category has many products. As a foreign key, we set the category ID, and we will not use a through model. We run lb relation a second time. This time the first model we select is the product model. The relationship type is belongs to, and we select category as a second model. The name of the relation will be category, so product belongs to a category. As a foreign key, we set category ID, and this type of relation will not ask for a through model. When we look at our products model, we see that a new endpoint got added. This endpoint can be used to interact with the new relationship. In the category models, we see a few endpoints that allow to interact with the products relationship. Let's create some data to see how this works. Let's add a category drinks and food. And when we look at our endpoint, we see we have the two categories in place. In the products model, we add coffee and tea and add it to the first category. And we add lemon cake and cheesecake and add it to the second category. When we look at our products endpoint, we see that the categories got added. To see the relation working, we can go to the category model, open the get endpoint for categories ID products, and enter a category ID. We will see that this will return only the products in this category. When we change the ID, we see that we get the products of the other category. We can also view which category is related to a product. To do so, we go to the get products ID category endpoint and enter the ID. We will see that this product belongs in category drinks, and we see that this product belongs in the category food. Now if we look at our project, we see how the relations are defined. In the categories model, we find a new relation under the products key. It defines the type of relation, the model it relates to, and the foreign key. In the product model, we can see that the category ID property got added and that the relation called category is also defined. We run lb remote method and select the product model. The name of our remote method will be by. This is not a static method, so it will live on the prototype. The description will be by this product. The HTTP endpoint will be /by and the verb will be post. Then we hit enter because we only want to add one endpoint. Next, the generator will ask us which arguments we want to accept. We enter quantity, which is of type number and is required. And as a description, we will enter number of products to buy. We will let loopback auto-detect where to get the value from. And because we only need one argument, we will hit enter. Now the generator asks us what we want the remote method to return. The name of our argument will be result, which is of type object, and it will be the full response body. As a description, we will enter the result of the purchase, and we hit enter to finalize the generator. The generator tells us where it created the metadata and where we can define the actual remote method. It also gives us an example method we can use in our model. When we look at product.json in our IDE, we see that our buy method got defined here. When we open the API Explorer and look in the product model, we see that our new endpoint got defined. When we enter the ID of a product and the quantity and execute the remote method, we see that we get an error message. This is because we did not define the actual method, only the metadata. Let's open up product.js and paste in the example code from the generator. When we execute the method again, instead of an error message, we now get no content. This is because our result variable is empty. When we change it to an object literal and enter the quantity, we finally get a result. We can make the method a bit more useful by changing the result to an object with a status key and a friendly message. The result will now say you bought one product. Now there's one thing we need to fix here, and that's that we don't want to allow a quantity less than 1. To do this, we first create a helper method in our model that checks for a valid quantity. This method will return false if the quantity is smaller than 1. Now we add a condition in our remote method that invokes the helper method. If the quantity is too low, we will return our callback with an error message. Let's try this out. We enter a quantity of -1, execute it, and an error message will be returned. We create a validation rule by adding a static method to the model class. The method name is validateslengthOf. The first parameter is the property, name. The second parameter is an object that configures the validation rule. To force the minimal length, we set the value of min to 3. Let's try this out. We go to the put products endpoint and pass in our data. When we see the result, we see that we get a validation error. This error message can be enhanced, so let's add a custom message. We can do this by adding a message property, and for the key min, we add a custom message. When we try again, we see our custom message. Another thing we want to validate is that the name of our product is unique. To do this, we can use the built-in validates uniqueness of rule. When we try to resubmit the same product twice, we'll see that we get an error message saying name is not unique. For the price of our product, we want to make sure it's an integer and the value is 0 or higher. Because loopback does not have a built-in validator for this, we'll write a custom one. First, we'll add a regular expression that we can use in our validation method. Then we'll add a validation method that takes one parameter, which is the error callback. The method uses our regular expression and triggers the error callback when it does not pass the test. The last thing we want to do is add a validate rule, pass in the property, price, add a reference to the validation method, and pass in a friendly error message. Now let's try this out. When we look in the API Explorer, we see that we can't add any products with the price lower than 0. Great. Another common use case is to use an asynchronous validation. For instance, if you want to validate against the value in the database, or if you want to call into an external service like an API. We'll add a validation method that works asynchronous using process.nextTick. We pretend to get a minimum value of the database and validate this against our price. Once we have our validation method in place, we will add a validate async rule, pass in our property price, add a reference to our validation method, and print a friendly error message. Let's try this out. When we try to add a price of 1, we see that our validation rule prevents the product from being added. When we add a price of 100, we see that the product gets persisted. We install Mocha and Chai as dev dependencies. We open up our package.json and modify the script section. We remove the post-test script and add a test script. The test script runs Mocha on all the files with the extension .test.js in the test folder. We also add a script test::watch that runs the npm run test script and passes in the watch parameter to Mocha. We create a file test/common.js which will serve as a helper for our tests. Here we create a reference to our loopback server called app. We require chai and get expect from chai. In the last step, we export app and expect, which we will use in our tests. We create the file test/unit/product.test.js, and in that file we'll create our first test. We include app and expect from common, and we will get a reference to our product model. We add our first test, and in this test we'll call into the product model and call find, and we'll log out the results. When we run npm run test, we see that we get an error message. The error message is that it can't find any files matching the pattern. We look in our package.json, we see that we made a typo here. Let's fix that by using the right path. When we now run our test, we see that we pass. What this test also shows is that it uses our default database connector. One way to fix this is to override the data source for a specific node environment. In our package.json in the script section, we override the environment of the test command by prefixing the command with nodeenv equals test. This means that Mocha will run using this nodeenv. We copy server/datasources to JSON to server/datasources.test.json, where test is the name of the node environment. In our copied file, we set the DB connector to false. When we run our test again, we see that it passes and that our test returns an empty array. Now let's run our test in watch mode and add some actual tests. In this test, we test our product.buy instance method. We create a new instance of the product with these parameters and run the buy method on the instance. As a parameter, we pass in the quantity of 10. In our callback, we verify that we have the right return status. In our second test, we initiate the same product. This time we run the buy method with a negative amount. In our callback, we verify that we get the error that we expect. Now let's add some tests to ensure our validation works as expected. We test if our product name has the expected length. We do this by calling into the product.create method with a new product as the payload. Product.create returns a promise, and in the catch block we verify that the error message and the status code are as we expect. We do the same for duplicate name. We start our promise chain with a promise.resolve, and then we run the product.create twice with the same product details. In the catch block we verify our error message and status code again. Here we test the product price. We test the same way as with product name, but this time we enter a price with less than 1. The error message should contain the string price should be a positive integer. In this test we verify that we cannot add a price lower than a minimum of 99. For good measures we also add a test to verify that a correct product gets added in the way we expect it to. Inside our product model class we'll add a new static method called product.observe. As a first parameter, we pass in what we want to observe, in this case before save. The second parameter is a callback method which takes 2 parameters, ctx, which stands for context, and next, which is the callback. Inside our method, we create an if statement where we check if we receive an instance on the context and that this instance has a category ID. Below the if statement, so when our condition is not true, we return next so loopback can continue its work. Inside our if statement, we will check if the category where we want to add the product to exists. We do this by getting a reference to the category model through our product model. On the category model, we run the count method, and as a parameter, we pass in that we want to count the categories that have an ID matching to our requested category ID. The count method returns a promise with the number of items. In the then block, we check if the number is lower than 1. If so, we return a promise.reject with an error message. In our product test, we will add a new section where we'll test our hooks. In here we create our test. We will try to create a new product, and as a category ID we pass in an ID that does not exist. In the catch block we verify that the error message is what we expect. When we run our test we see that our new test passes. In our category model we will add a before delete observer. The callback only takes the context because we will directly return a promise. Inside our method, we get a reference to our product model through our category model. On the product model, we run count, and as the parameter, we pass in that we want to count the products that have a category ID matching with the one in our context. In the then block, we check if the number of products is higher than 1, and if so, we return promise.reject with an error message. We create the file category.test.js in our test/unit folder, and we require app and expect from our common file. Next, we create a reference to the category and the product models. We add a describe block for category, and inside that describe block we add a block for the hooks. In our test, we start the promise chain with a promise.resolve. Then we create a category called myCategory, and we get the result in the second then block. We will use the ID of the result to create our new product. So after product.create ren, we have a category with 1 product. In the third then block, we use category.destroyById to delete the category. And in our catch block, we verify that we get the error we expect. Now if we save our file and run our test, we see that the category test passes. Inside our loopback project, we run lb_acl. This will prompt us for a model name. We choose product. The generator asks for the scope. We choose all methods and properties. For access type, we select all. For the role, we select any unauthenticated user, and for the permission, we explicitly deny access. Now if we look in our model definition, we see that we have a new object in the acls array, which describes what we just created. Let's try this out in the API Explorer. We start our server by running npm run dev and open the API Explorer in the browser. When we go to the get products endpoint and we try it out, we see that we get an error message saying authorization required. Now what we actually want to do is only allow the get products endpoint, but disallow any other operations. That way unauthenticated users cannot modify any data in our API, but can list it. We hop over to our terminal and run lbacl a second time. We select product, a single method, enter the name find, select any unauthenticated user and explicitly grant access. In our product definition, we see that a new ACL rule got added to the ACLs array. When we start our server again and we try the same endpoint, we see that we can now list our products. Other endpoints like delete/products still return authorization required. Because we want to have the same ACLs for the category model, we just copy the content of the ACLs array from product.json and paste it in the ACLs array in category.json. Instead of verifying through the API Explorer, let's add some tests to make sure our permissions are set as expected. We create the file acl.test.js and start by requiring app, expect and request from common. We currently don't export requests, so let's open our common.js, require supertest, create a constant called request, which loads our app into supertest, and export request. Because we did not install supertest yet, we go over to our terminal and install supertest as a dev dependency. Inside our ACL test, we create a new describe block for the ACL. Let's begin by testing the category model. In the first test, we want to list the products and expect to have an HTTP 200 response. In the next 3 tests for creating, updating and deleting a category, we all expect an HTTP 401 authentication required response. When we run our test, we see that they pass. We add the same test for the product model. List is allowed, create, update and delete are denied. And for the product model, we have an extra test for the buy method. When we run our test, we see that we have one failing test. The buy method expected to be allowed but was denied. We can fix that by opening product.json and change the string find into an array with find and buy. When we run our tests again, we see that they now all pass. In order to access the API as an authenticated user, we need to have an access token. We can create an access token by logging into the API. Because we don't have a user yet, we first need to create one. In the API Explorer, we go to the post/users endpoint. In the data field, we enter a JSON object that has an email and password property. When we hit try it out, we see that the user got created. Now if we scroll all the way down, we see that there's a /user/login endpoint. When we enter the same credentials and we hit try it out, we see that we got a valid response. The actual response body of the API is our access token that got created. And we can use the ID field of this result to identify ourselves. We copy the ID and paste it in the box in the top right corner. We can now make authenticated requests to the API. When we go to the /post/categories endpoint and we try to add a new category, we see that this works as expected. If we remove the access token and we try it again, we see that we get an authorization required error message. To have our API create an access token on start, we can use a bootscript. In our project, we run lb bootscript and as a name, we enter create access token. As a type, we select async. When we open our newly created script, we remove the code that got generated. The first things we want to include is a reference to the access token and the user model. Then we set 3 variables, email, password and the access token that we want to have created. We start our promise chain by returning promise.resolve. In the first then block, we try to find the user by its email address. In the second then block, we return the user if it got found, and otherwise we create it using user.create. In the third then block, we will create an access token using the variable access token that we set above and the ID of the user that we got passed in as the user ID. We then console log the ID of the generated access token to the terminal. We finalize the chain by using Bluebird's asCallback CB method to return CB. When we start our server, we see that there is an error message. asCallback is not a function. To fix this, we go to the top of our bootscript and require Bluebird. Because Bluebird is shipped with loopback version 3, we don't need to explicitly install it as a dependency. We see that our server now actually starts and that our created access token got printed in the terminal. When we go to the API Explorer, we can verify that we can use this token to authenticate. In our server folder, we create a file datasources.local.js. In this file, we can dynamically control our data sources. We start by adding a const called mongodb URL equals to process.env.mongodb_URL. This allows us to control the MongoDB URL with an environment variable. We then add an if statement that checks if the variable is set, and if so, we'll print the URL. To see if this works, we'll start our server prefixed by the MongoDB_URL environment variable. In this case, I enter the URL to a MongoDB server that I have running on localhost. Now, to connect to the actual database, we need to pass in the database configuration. We create a const called datasources, which is an object with a key of db, which is a reference to our data source. We define an object with 3 keys. For name, we use db. For connector, we use MongoDB, and for the URL, we pass in our local reference to our environment variable. The last thing to do is to export our data sources using module.exports equals data sources. When our server restarts, we see that we get an error message. Loopback tells us that it cannot create the data source db because the MongoDB connector is not installed. Luckily, it also gives us a command to fix it, so let's run that command. When the connector is installed as a dependency and we start the server again, we see that it now starts as expected and that it connects to MongoDB. If you try to connect to a non-existing MongoDB server, you'll get an error message as well. So make sure you connect to a server that exists and that is accessible. In our browser, we navigate to mongodb.com. We click Cloud and then MongoDB Atlas. Click the Start Free button to create a new account or log in if you already have one. Enter your email address, your password, tick the box to agree to the terms and service and click Continue. Enter your account credentials, create a group and click Continue. Once our account is created, we are prompted to create a new group name. We enter our group name and select MongoDB Atlas. Inside our group, we can now build our new cluster. When we scroll down, we see that there's a free option. We select the free option and verify that our price is $0 forever. When we scroll all the way down, we see that we have to enter an admin username and password. We enter admin and have the site generate a password for us. We store this password as we need it later. We can now click Confirm and Deploy to have our cluster created. When we verify our identity, we see that the cluster is being created. After a few minutes, our cluster got created. We navigate to the Clusters tab and click the Connect button to get our connection string. We can use this connection string to connect our applications to our MongoDB cluster on Atlas. Please make sure to replace password and database in this connection string. We can use filters to manipulate which data gets returned by loopback. Let's see this in action. We will interact with the get categories and get products endpoints. I use the API Explorer to create some sample data to play with. We can apply the filters using URL parameters. For example, with the include filter, we can include the products that belong in a category. Now let's get to our products endpoint and we include the category in the result. We use the order filter to sort on price ascending or descending. We add a where filter to only return all products with a price higher than 200. Using the where filter, we can also do a wildcard search using like. The filter fields is used to only show certain fields. When filtering on fields, we see that our category is no longer included in the results. To fix our include filter, we need to make sure that we add our foreign key in the fields filter. Once we add category ID to our fields filter, we see that the category is included again. Next, we add a limit filter to limit the number of items in our result. And we can use the offset filter to skip items from the result. The last two filters can be useful if you want to page through the data. We install now globally using npm. When the installation is finished, we run now --login to log in or create an account. Follow the instructions on the screen to confirm your account. Inside our loopback project, we run the command now to start the deployment. This will upload our project to the now servers and run npm install. We already get the deployment URL, and when we open that in our browser, we can follow along with the progress. When the dependencies are installed, now we'll try to start our server. We see that it fails because it cannot open db.json, the file that we have referred to in our in-memory data source. Let's fix this by connecting our API to the MongoDB instance on Atlas. We add our MongoDB URL as a secret to now. Next, we start now with the environment variable MongoDB URL set to @mongodb-URL. By using the @sign in our environment variable, now knows that it needs to use our secret as a value. Awesome, our API is deployed and in the terminal we can see that it's connected to MongoDB. The page in our browser is refreshed and we can visit the API Explorer. We start by listing out our categories, which is an empty array. Using our access token, we see that we can add new categories. Now let's open up our package.json and create some scripts and configuration for now. On the top level, we add a new property called now. Inside this object, we add a property called name, which is a string, which we set to egghead-loopback. Next, we add a property called alias, which is an array, and in that array, we add a string called egghead-loopback. The last property we add is called env, which is an object. And in this object, we add a key called mongodb_URL, which we set to @mongodb-URL. For good measures, we also set our node env to production. We then move to our script section where we add a script called now:_deploy, which executes now. We add a second script called nowalias, which executes nowalias. The last script we add is just called now, and it invokes the other two scripts. We save our file, we hop over to our terminal and run npm run now. We see that our project gets deployed, and once that's done, we get an alias that we can use to access our API. One thing to note about using a free account of Now is that the deployments are public. This means it will show the source of the project you're running when visiting the _src path on your project. If you subscribe for the paid plan, your projects will be private by default.